network. So let's look at the rules first. So we know that the reason for networking is to provide a means of communication, all right, or a means of sharing resources. So, and these communications have some common elements. So, which is the message, the source, or the sender. Okay, so that's the first element. The first element is the message source, right? So the message source is the sender, and the message source is which is the first end device, who is the sender. It can be your phone, alright, your mobile devices or end devices generally that is being used to send the first information, right? That information can be a request, okay, it could also be data that is being sent. And the second element of communication is the destination, which is the receiver or the end point of um the information that is being sent or the message that is being sent. And the receiver is definitely also an end device, right? And the third element is the medium, okay, or the channel via which the message passes through to get from to move from the sender to the receiver. So to look at communication protocols. So there are communication protocols are just like the rules that govern communication, govern conversation generally. So look at we're talking about the method of communication we should use, the language that we should use, and how we would confirm or affirm that our messages have been received. And these rules or protocols are followed for message to be successfully delivered and understood. So just like in English, we have different rules. We have semantics, we have the lexis, or actually the lexicon is a dictionary. We have um, alphabets that make up English language. So there is also syntax, all right, such that all these things are put in place so that we can have something that would define um, or will approve a sentence to make sense, or that will validate whether a sentence makes sense or not. So that's the same way we have these protocols in networking. So these rules now we have an identified sender and receiver. We have the agreed upon method of communication, either face-to-face telephone, photograph, letter, or so on and so on. We have common language and grammar. We have speed and timing of delivery. We have confirmation or acknowledgement requirements. Right, that's when we talk about the handshake in communication, just to affirm that message has been received by the receiver. So why does protocol matter? All right, we have the characteristics of protocol. We have the message format. All right, that's the type of message that is being sent and the channel that is used to deliver the message. We have the message size. All right, so the length of the probably characters or the size of packets, okay, that's what will determine the message size. So longer messages might break for it to get to the receiver. Then timing, okay, the speed at which the bits are being transmitted across the network. We have encoding. So encoding is when a message is being sent, it's being encoded first, so it is converted into bits, all right, before sending to a receiver. Then encapsulation. So encapsulation is the process of adding the information into the pieces of data that make up the message. Then message pattern. So some message require an acknowledgement before the next message can be sent. So um, the type of request or response pattern is a common aspect of many networking protocols. So we have a lab that we're going to do there also. So let's look at communication standards. All right. So a standard is a set of rules that determine how something must be done. Okay, so in networking, there are standards for communication. And networking and internet standards ensure that all devices connecting to the network implement the same set of rules or protocols in the same manner. So in using these standards now, it's possible for different devices to send information to each other over a network, right? Remember, we have different kinds of devices. A phone can be used to send a message to a PC, and the PC will understand or be able to read the message, right? So that's because they both follow a particular standard in sending one message from one point to another. So um for example, now here it says that the way in which an email is formatted, forwarded, and received by all devices is done according to a standard. So if one person sends an email via a personal computer, another person can use a mobile phone to receive and read the email, as long as the mobile phone uses the same standard as it was personal computer. Exactly what I just finished explaining. So an internet standard is the end result of a comprehensive cycle of discussion, problem solving, and testing. So when a new standard is proposed, each stage of development and approval process is recorded in a numbered request for comments. That's an RFC document. So these RFC documents are being managed by the IETF, which is the Internet Engineering Task Force. Okay, so there are also other organizations that support these standards or that come together to agree on these standards. That's why we have the ICANN, the TIA, the ITU, the IEEE. Let's look at network communication models. There's a video that you would watch on the you have to watch on the course itself. So first of all, look at the protocol stack. So before communication can happen, alright, or can be successful between two devices, right? There are certain standards that must be following, that must be protocols that must be followed, right? We have the HTTP, we have the TCP, we have the IP, we have the Ethernet, alright. So a stack illustrates the protocol as a layered hierarchy, with each higher level protocol depending on the service of the protocols shown in the lower levels. So the separation of functions enables each layer in the stack to operate independently of others. So which means that a server now, right here we have a server, we have the internet, we have an end device. So a server can actually observe, right, or observe any of all these protocols or multiple of all these protocols simultaneously. So your server can offer mail services at the same time, offer file transfer services. We'll get there. So let's look at the first one. We have HTTP, which is Hypertext Transfer Protocol. It says this protocol governs the way a web server and a web client interact. So HTTP defines the context and formatting of the requests and responses that are exchanged between the client and the server. So HTTP works over the web. Right. Then we have the TCP, Transmission Control Protocol. It said this protocol manages the individual conversations. So TCP is responsible for guaranteeing the reliable delivery of the information and managing flow control between the end devices. So when one system wants to communicate with another system, this time around not a server, so that's where the TCP protocol comes in. Then the IP, which is Internet Protocol, is responsible for delivering messages from the sender to the receiver. So IP is used by routers to forward the messages across multiple networks. So when someone is on another end of the network. So it is this IP that enables a message to get from one host to another host. Then Ethernet protocol is responsible for the delivery of messages from one network interface card to another network interface card on the same Ethernet local area network. The keyword here is Ethernet local area network. So the Ethernet, Ethernet is cable, right? It works with wired medium. So definitely it's going to be a local area network. We can use a wired net medium to create a very sophisticated um, network topology because you'll be limited. So let's look at the TCP/IP model. TCP/IP model has four layers. All right, we have the application layer, transport layer, internet layer, and network access layer. So the layered model has many benefits. The benefit of TCP/IP is it assists in protocol design because protocols that operate at a at a specific layer have defined information and they act upon they act upon and a defined interface to the layers above the below. Then it also fosters competition because products from different vendors can work together and enables technology um, changes to occur at one level without affecting the other levels. And TCP/IP
Carry that
also
thing, turn that, put am
provides
inside.
a
So that
common
the go
language
turn the
to
cable.
describe
No, that's one.
networking functions and capabilities. So the application layer represents data to the user plus encoding and dialog control. Then for the transport layer, it supports communication between various devices across diverse network. Then the internet layer determines the best path through the network. And network access layer controls the hardware device and media that makes up the network. Then the OSI model has 7 layers. All right, you have the application, presentation, session, transport, network, data link, and physical. So this layer is built from bottom to top, not from top to bottom, including the TCP/IP reference model. So the physical layer describes, I'm starting from the bottom now, the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connections for a bit transmission to and from a network device. So physical layer, some devices that you could liken to be on the physical layer are things like your hubs, right? Your Ethernet cable, right? Those are items in the physical layer. Then the data link layer. So it describes methods for exchanging data frames between devices over a common media. Okay, so that's more like even the hub. All right, then we have the bridge. Also, that's also on the data link layer. We have okay, yeah, a bridge, and this I'm trying to remember the name. There's something I use to amplify a network over a long distance because as when a specific amount of length has been covered on an Ethernet cable, you would need to it's called a repeater. All right, a repeater is under the data link layer. Then we have network. So the network layer now, it provides services to exchange the individual piece of data over the network between identified end devices. This is where routers come in, switches come in. Okay, this is where switches come in. Then we have the transport layer. The transport layer defines services to segment, transfer, and reassemble the data for individual communication between the end device. Then session layer provides services to the presentation layer to organize its dialogue and to manage data exchange. Then presentation layer provides for communication representation in the data transferred between application layer services. Then the application layer contains protocols used to process used for process to process communications. So the applications are the ones that you the application layer are just more like the interfaces, what those apps to interface directly on your system before you can even communicate in the first place. So the OSI model is actually divided into the upper layer and the lower layer. So the upper layer is made up of the session, presentation, and application. The lower layer is the physical data network and transport layer. So you are seeing here that the upper layer um have different network components, right? You can see what I was talking about in the physical layer. You can see what I'm talking about in the data link layer. You can see um the network layer, examples of devices, and transport layer, examples of devices there. So like I said earlier, physical layer, you have your Ethernet cables, right? Anything after that is physical that you use to connect a host device to a network. Then for data link layer, you have your wireless connectivity, all right, network switch, and network interface. Then we have for the network layer, we have your routers, right, your IP addressing. Transportation, the transport layer, we have your firewall, video and voice streaming mechanisms. Then for the upper layer, under the session presentation application, that's where you see your email, your web browsers, right, your um cloud file transfer protocols, right, where you see your Google Drive. Okay, those softwares are enable you to what? Transfer data over the network. So in comparing the OSI model to the TCP/IP model, in TCP/IP model, the application layer just grouped the application, presentation, and session layer of the OSI model. Then transport layer could be something similar to the same functionality of the transport layer. Then the internet layer is similar to the functionality of the what network layer in the OSI model. Then the network access layer is similar to the in function to the what physical and data link layer of the OSI model. Let's look at the Ethernet. The rise of Ethernet. So there we talked about the different standards for crimping cables, right, or for using twisted pair cables. So
Yeah.
yeah, twisted pair cables are what make up the Ethernet, right? So in the early days of networking, each vendor uses its own proprietary methods for interconnecting network devices and network protocols. So as networking now became popular, right, that was when this rule was actually developed so that devices would be compatible, would work on with the same rules. All right. Remember we talked about the rules for communication. Imagine everybody just have their own rule. So it's just like this country is just using only just like we have different languages in Nigeria now, and things can be done differently in those different languages. How can we come together to communicate or do business together if we do not if our devices cannot understand each other, if we ourselves too cannot understand each other? That was why this was actually released. So this they say the standards are beneficial to network in many ways. It helps facilitate design, simplify product development, promotes competition, provide consistent interconnections, facilitates training, provide more vendor choice for customers. Alright, so all vendors would now use the same rules to produce their equipment, just like Cisco routers and Huawei routers. So their ports, it's the same network port that is used in every computing device. So when you're talking about an RJ45 port, it's the same port. There's no one that is smaller. There's no one that will say, okay, just like where we have different chargers for different laptops. And although they are meant for the same purpose, which is charging the system, but now we have different charger ports, right? We could have big pins, small pin, medium pins, or small pins, or even square pins, or now you will have type C charging ports. But now in networking too, because networking is something that is very, very crucial, that's why there was need for this standard or this rule to be implemented so that it will ease communication between different vendors, and that's what was going to promote competition. So there is no official local area networking standard protocol, but over time, Ethernet has become the most common. So Ethernet protocol defines how data is formatted and how it is transmitted over the wired network. And the standards specify protocols that operate at layer 1 and layer 2 of the OSI model. So Ethernet has become a de facto standard, which means that it is a technology used by almost all wired local area network as shown in the figure. So we have um, both routers and system. You can see like what I said earlier, all systems use the same Ethernet ports. You would not see a system that has a different network port. So even if your system does not have a network port, you would have to now use what USB to um, network adapter. So the IEEE maintains the networking standards, including Ethernet and wireless standards. So each technology standard is assigned a number that refers to the committee that is responsible for approving and maintaining the standard. So for the Ethernet standard, the IEEE standard for Ethernet is 802.3, and there are different versions that are associated with this standard. So for example, there's 802.3 100 base T. So the 100 is the speed, right? The base stands for baseband transmission, and the T stands for the type of cable. In this case, T is what twisted pair cable. So remember we talked about the 802.3A, 802.3B for the twisted pair cables. That was when we now talked about crimping the two different cables in different ways. One for um, copper crossover, the other for copper straight through, whereby um, the copper straight through should be used for devices with different used for different devices. Then copper crossover should be used for similar devices. So early versions of Ethernet were relatively slow, which were they moved at speed of 10 Mbps. But the latest versions of Ethernet operate at 10 gigabits per second and more. So Ethernet, if you notice on every network adapter has a MAC address. Alright. So all communications require a way to identify the source and destination. And the source and destination in human communication are presented by names. Alright, when your name is called, you listen to the message and respond. Other people in the room may hear the message, but they ignore it because it is not addressed to them. So on Ethernet network, a similar method exists for identifying source and destination host. So each host connected to an Ethernet network is assigned a physical address which serves to identify the host on the network. So every Ethernet network interface has a physical address assigned to it when it is what manufactured. So every MAC address, which is the media access control address, is embedded on every physical network device. So whether it is wireless or whether it is wired. So a network interface port has a MAC address. A wireless card has a MAC address, and it cannot be changed. So that's the end of communication principles. Right. So the next thing we'll be looking at is network design and access layer. I'm going to change what I'm presenting.